In this video, we're going to look at brief examples of joint variation. We're going to define joint variation. Y equals k times x to the n times z to the n. And so one thing you should notice right away with joint variation is you're going to be dealing with more than just your two variables as before. Your direct variation, your inverse variation just had a y and an x in relationship to your constant k. Here, joint variation, you're going to be dealing with in this three variables. So we have the phrase y varies jointly as x and z. And so we have the product of your x and your z with your constant should give you your y value. So our two examples we're going to look with are the volume of a cone varies jointly as the height and the square of the radius of the base. And so again, you can see as your height and the radius of the base increase of a cone, well, that means the volume is going to increase as well. So the question here is going to be, what is the value of k? So we have k times our height. It varies jointly as your height, and so that's our x. Volume varies, volume of a cone varies jointly, so volume of the cone is your y. Your height is x, and the square of the radius we have is our z. So the question is, what is the value of k? And this again is our formula. The volume for a cone is 1/3 pi r squared h. Well, I can see my r squared, I can see my h, so that must mean my constant of variation is represented by 1/3 pi. And so that is a joint variation. You're using multiple variables in relationship to the y. So the area of a triangle varies jointly as the base and the height of the triangle. So again, area of a triangle varies jointly. So area of a triangle is your y to the base, which is your x, and the height of the triangle, which is your z. So A equals some constant k times your base and height of the triangle. So what is your constant of value? What is the k? And so area of a triangle is represented by the formula area equals 1/2 base times height. And so here then, that means my constant of variation, here's my base, here's my height, so that must mean 1/2 is the value of k. And so joint variation is very similar. I like to compare it to direct variation. Joint variation is very similar to direct variation. It's just instead of just an x and a y, you're going to be using multiple variables. The constant of if one increases, so will the other still holds for the joint variation.